But in this session, we are going to formulate energy-work relation. Now, in order to formulate a energy-work relation, let us take an example. Suppose we have got some object which is moving with the velocity of u meter per second, and we applied a certain force F on this body. And let us assume its final velocity will be v meter per second. So what is the kinetic energy of the body when the velocity is u meter per second? So its velocity, when its kinetic energy, when its velocity is u, is equal to, we know that the relation of kinetic energy is equal to half m and velocity square, and the velocity is u, therefore the velocity at this moment is u square. Now, what will be the kinetic energy of the body when its velocity is changed from u to v, and now the body is moving with the velocity of v meter per second? So its velocity, its kinetic energy is equal to half mv square. So what is the increase in the kinetic energy? So this is the final kinetic energy and this is the initial kinetic energy. So the increase will be the final kinetic energy minus the initial kinetic energy. So the final kinetic energy is 1 over 2 mv square minus 1 over 2 mu square. Now if we can factor it out, 1 over 2 m, so 1 over 2 mass, m is the mass of the body, and you are left with v square minus u square. Now we know that v square, we got a relation. Now v square is equal to u square plus 2as. Now from here you can find out v square minus u square is equal to 2as. So we replace the value of v square minus u square here, 1 over 2 m, and the value of v square minus u square is 2s. Now this 2 is cancelled with 2 and you are left with ma into s. Now from the second law of motion, F is equal to ma. Therefore we can write F for ma. So you are left with F dot s, of F multiplied by s. And what is F multiplied by s? Now F into s is the work done by the body when a F Newton force is applied on the body and it displaces the body to a distance of s meters. So this is work done by the force. So what is the final conclusion? So we have started from here, and this is the change in the kinetic energy or increase in the kinetic energy. And ultimately you have arrived at work done. So we can say that therefore increase in the kinetic energy is same as the work done by the force which accelerates the body and which moves the body from velocity of u meter per second to v meter per second. So work done by the force. So this is a very important relationship between these two quantities, that is the increase in the kinetic energy and the work done by the force. So ultimately we have concluded this thing, that increase in the kinetic energy is equal to the work done by the force.